Yeah, let me just share. Yeah, so let me just share my screen and go ahead with the leaderboard that we have from last session's quiz. So here we go. So as you can see, there are 17 people this time who have touched the 15 out of 20 mark uh, at this time. And it's quite exciting to see that. So we have Tirala Shivakumar, Rakshita, Puna, Paneni, Sri Pujita, Uppalapati, Osu, Mohammad Abdul, Jahir, Himaja, Shiva Prasad, Saripaka, Tha, Dhananjay, Vendra, Sudarshan, Venku Mahanti, and Parimala. So the reason I've marked the top four is because they were quite close to perfect 20 score, and I am sure that coming soon, a lot of you students who are there on the leaderboard and all other students who are working their way towards the leaderboard will be able to pull off these numbers and even better for that matter. So without further ado, I will get back to the point that I discussed earlier, where we will discuss a few questions, few important questions that were part of the quiz earlier, and we will discuss the answers and why a lot of you got it wrong. And just remember that we are not going in depth of these questions because we have to keep the session on time. So Deepak Chaudhary, our expert, will be just taking you through an overview of these questions. And if you have follow-up questions regarding the same, then I'm just going to post one link over here in the chat box. So make sure that you uh, go on the link and then ask questions regarding any of the problems that you might have faced during the quizzes, or if you got your answer wrong, then what is the correct answer. And all of those questions, I want you guys to interact with our mentors and experts on Discord and just ask why was the answer wrong or why it should have been the other way. So Deepak, I want you to just let's begin the session and review those questions.
Yeah, thank you, Deepak. Yeah, good evening, guys. Let me share my screen. Okay, so I'm going to discuss some of the questions where most of you find difficulty to solve. In that, first question is this one. In this, which of the following is immutable by default in Rust, but we can made it mutable? As we have discussed several times that if we make a variable just like this, let b equals to 10, then by default it is a immutable. So we need to make it mutable. We need to put mute before the variable name. Okay, next is this one. What can be the other name of loop in the Rust? This question we have already discussed in the previous session. Let me show you where we have here. The other name of loop is infinite loop, while is conditional loop, and for is iterator loop. Why this is? Because for coming out this loop, we need some conditions to coming out from this loop, like break or something else. In while loop, we put some conditions in the while condition, and for iterator loop, for loop, let me show you one here. What we are doing is we are iterating through 1 to 10, and here 11 is exclusive. We are iterating through 1 to 10 only. Okay, so the correct answer for this is infinite loop. Next question is the 11th. Okay, so how many times the for loop will execute? I have just showed you, like this for loop is start from 1 to 10. So for loop will execute for 10 times. So the correct answer is 10. Okay, next question is 14. Okay, what will be the output of block code below? Here we are defining the n is float and we have defined a function and we are returning the 5, then the answer would be the 5 for this question. Next question is 16th. Okay, here what we are doing is we are defining the n is float, and in function what we are doing is we are taking this n and returning the n which is 1.0, which is float. Also there's many conditions to have this an error. So some of you most of you have take the option is 5, so that is not correct. We are not returning the x here, we are returning the n. Okay, next is the 17th. Here it's clearly seen that we have declared n is immutable and we are trying to change the value of n. Then it is clearly this program is clearly not execute successfully. Some of you might confuse here because plus equal to operation is not allowed. So that is not correct. Plus equal to operation is allowed. Okay. So the correct option for this question is this one, second. Program doesn't execute successfully. Okay, next question is 18th. A named block of code that does some work but does not return a value. Choose the most appropriate answer. This exactly question we have discussed in previous session. Let me show you where we have discussed. When we start discussing function, we have discussed both the things. What is function and what is procedure. The name block of code that does some work but does not return a value is procedure, and a name block of code that returns a value is function. So the correct option for this is procedure. Second option. Okay, I got one query regarding this question. Let me show you how can we do this. For defining const, what we have done is const pi. We need type annotation here. Okay, if we remove this, then we face error. For defining const, we need type annotation. Okay, now next is the last one. How many times loop will run? Okay, let's just see this loop. We are talking about this loop. We are not adding any condition to come out this loop. We are just increasing the counter and print it. That's it. So this loop will run infinite times. So the answer for this is infinite. Some of you have marked 10 times, so that is not correct. The correct answer is infinite. Okay, let me see some Q&A if someone have any doubt.
All right. So first of all, thank you, Deepak, for the quick overview. So guys, just remember that these are just a few questions that we have addressed here, keeping things, trying to just manage things in time. But at the same time, if you have any more questions, any more doubts, you want to get into the details of things that we're discussing here, or any other question for that matter of this entire quiz or multiple quizzes that we'll be doing or we have done, just hop on the link that I have shared in the chat box. Just go over there, put your queries, and we'll address it. Now, moving on. So we will get back to the
One question is Q&A
Yeah.
is quick quiz result. Guys, we have released all the results. And if you haven't find the result, please go to the promotion in your Gmail. You can find it.
Okay, yeah, the top 10, Mohammed Abdul, we have already addressed it earlier. Requesting you to please be on time next time. Okay, guys, so thank you once again, Deepak, and we'll move on to our star of the evening, our expert trainer, Mr. C. Selvaraju. Selvar sir, over to you. I hope we have not taken a lot of time, but at the same time, as we have discussed with all the students here, that we'll be discussing these questions in our Discord. So, guys, just remember the Selvar sir, Deepak, they all will be there to help you out in the Discord channel, that the link of which I have already shared. So if you have any more doubts regarding the quiz or the sessions, just hop on over there and we will discuss it with you and help you out. Selva sir, over to you.
Thank you, Deepak. Okay, good evening, ladies and gentlemen. So let us start today's session. So today we are going to talk about one of the most important aspects of Rust programming language. Oh, by the way, am I audible?
Yes, sir, we can hear you properly.
Okay, right. So that deals with the ownership and borrowing. Okay. Remember, one of the important things that I would like to tell you is that let me share my screen. Okay. And let's go here. So I'm going to explain it through the use of the Rust program and the Rust book itself. Okay, so it will keep your like pretty easy. You don't have to, look around for the code and stuff like that. But what is important is this ownership model is something that really confuses a lot of programmers in the beginning. But again, remember, it has to do with the way the language has been designed. Okay, right? So you have to understand that initial mistakes that even seasoned programmers, when they come to Rust, that they tend to make these mistakes because of not understanding this ownership. So ownership is something that you have to really master. Again, remember, it is not rocket science. It's it's actually quite simple. The only thing is the way things work in Rust are quite different, somewhat different from what you are actually used to. When, say, for example, if you're coming from C, C++ or maybe Python background, okay, these things, out of the box, they're not supported the way Rust does it. Okay, but the reason why Rust does these things is primarily to make your code as bug-free as possible. So many of the errors are caught during compile time itself. There is no need for you to run the code and check with the errors. Okay. Right. Now, in case if you are having any questions, so you can always come to this section 4 of the Rust book, and you can go through it. And anyway, I'll be explaining all the concepts in here. Okay. So why ownership? Why do we talk about ownership? Because one of the most important things is that ownership is the way Rust actually does memory management. And as I mentioned, the way Rust has been designed is such that most of the memory management related issues that come up in C and C++, okay, they are all avoided. So this is actually a best practice that is followed by Rust as core language feature itself. Now, you can have these things in C and C++ also, but they're not part of the core language because they've not been designed with that in mind. However, the support for the ownership and the borrowing, all these concepts are there as part of additional libraries. So you could use them, not that you cannot. Okay. But in Rust, these are part of the core language itself. So before we understand this whole memory thing, okay, is that, okay, you have to understand the whole concept of stack and the heap. Okay. So what I'm going to do is I'm going to show you a simple diagram to understand that. So basically in Rust, okay, so again, this is a very simplified view of how the memory is organized. by the Rust compiler. Okay. So you have on one hand, let's say, you have, let me increase the font size to 20, and you have stack memory and you have heap memory. Okay. Right. So memory is basically divided into two parts, the stack and the heap. Okay. And the way things work, actually, it's quite simple. See, stack is actually pre-allocated memory. Okay. This is pre-allocated. So when you say stack is primarily used for, this is statically allocated. Okay. Stack is always statically allocated. Okay. Whereas heap is dynamically allocated. Okay. So which means that when you have some variables in your code, okay, right? For instance, if you create a variable of simple type, let's say if it is an integer, okay. So if it's an integer, let's say I have an integer variable. I define it like this. So I have, let's say, let x, say it's I32, okay, and I assign a value of say 10. Okay. Then what actually happens? So we are allocating or we are creating a variable of type 32-bit integer. It has got a value 10. Okay. So in this case, what will happen is that you will end up with something like this. You have the value 10 here, okay, and you have value x. So this is the variable name, okay, and this whole variable is placed inside of this stack. Okay, so definitely it will also have some address. So the address, let's say 1, 2, 3, 4 is the address. Okay. So with any variable, okay, you will have three things associated with that. Okay. So one is the name. Okay. The name. The other is the content, or we can also call it as value. Content or value. And this is the address. That's the address. Okay. Three things associated. And of course, yes, this happens to be inside of the stack. Okay. Now, if you create a variable like so, okay. So if I create, so this is my code. Okay. So now here, let's say let s, okay, assign string from say ABCD, something like this. Okay. Then something different happens. So string is a complex type. Okay. Not a compound type, it's a complex type. So in this case, what happens is that you will get something of this sort. Okay, so this is the name. Again, this is the content or the value. Okay, and there's the address. So say 3, 4, 5, 6 is the address. Okay. However, the actual string ABCD, okay, this is placed inside of the heap. Okay. And this is created at some address. So let's say seven, something like this. Okay. And here this S, what it does not contain the actual content, but instead it contains the address. So what we say is that, okay, that this variable is pointing to this. Okay. So the string is actually created inside of the heap. So when it is created in the heap memory, it is dynamically allocated. Okay. Also, what happens is that this address 7777 is actually placed inside of this. The S itself, okay, is created in the stack, but the actual content is not here in the stack. Instead, it is inside of the heap, and wherever it is placed, that address is what this S contains. Okay. Right. Okay. Any questions so far, please? Because this is a concept that you have to understand very, very clearly. Again, remember, for the string, what I've done is I've given you a very basic idea. The string is actually a more complex data type than what you're seeing here. Okay. Any questions at this stage, please?
No questions, sir.
Okay. So always remember, stack is statically allocated and heap is dynamically allocated. This is all you have to remember to start with. Okay. Right. So when it comes to borrowing and ownership, you have to be very careful. So first, let's talk about the ownership, and then we'll go on to the borrowing part. Okay. So once you understand this, it will become very clear to you. Okay. But then again, remember, if you are coming from any other programming language background, okay, there are chances that you might make mistake because of this, but it can be debugged because the compiler will give you pretty good information regarding the mistake that you're making. Okay. If you're not understanding the whole concept of ownership and borrowing. Okay. Right. Right. Okay. So one of the ownership rules, if you look at the ownership rules, these are the 3 rules of ownership. Okay. Each value in Rust has an owner, and there can be one owner at a time. There can only be one owner at a time. And when the owner goes out of scope, the value will be dropped. Okay. So what it means is that when you have this variable X created somewhere, okay, when the X is assigned 10, what happens is X becomes the owner of this value. Okay, 10. X becomes the owner of this value 10. And when X goes out of scope, then in that case, X is destroyed. When X is destroyed, automatically the value associated with that is also destroyed. Okay. Same thing happens with the string S as well. So whenever the string variable S goes out of scope, okay, then S is destroyed. When S is getting destroyed, whatever it is pointing to, because S is having the ownership of the string ABCD in heap, this memory will get deallocated automatically. Okay. Now, let's say if you're talking about C++, what happens is that you have to use, okay, for dynamic allocation, you have to explicitly use some allocation function to allocate memory and then put the value in it. And you have to, like, for instance, you use the alloc or malloc, memory alloc function to do that, or you use the new operator to do that in C++. Okay, but when your string, or say this entity, is going out of scope, it is to be destroyed because you did the allocation yourself, dynamic allocation. Then what happens is you are responsible for deallocating the memory. Okay. Whereas in Rust, it is taken care of for you by the compiler. So in fact, the moment this goes out of scope, if it is pointing to 7777 address, and this is the owner. So whenever the owner goes out of scope, the value is also, okay, released. The memory occupied by that value is released. Okay. Devsri Prem Kumar, please do not put Q&As, do not use Q&A for your certificates, please. I think I have already mentioned this in my previous sessions as well. Okay, please don't ask these questions related to quiz answers or your certificates. Okay, you want to do that, you can contact it through Discord. Please don't use Q&A during the session for anything other than the session itself. Please keep that in mind, because ultimately we end up wasting our time looking at those Q&As. Okay, so let me just go back up here. Okay. So if you look at the variable scope, okay, so any block of code within curly braces is actually a scope, just like in C, C++, Java, C#, whatever languages, all these languages. Okay. So essentially, if I write a main function in here, let's say fn main, and inside this set of curly braces, I just define a variable, say let say n is assigned say 10, something like this. Okay. It is inferred as I32. So what happens is that any set of curly braces is actually a scope. Okay. Now, if I did something like this, okay, so I can even just create a new scope by simply using another set of curly braces. And let's say I have let x is assigned say 99 like this. Okay. And in here, if I use print line n is 10 and x is x. So this, you'll see that you'll start getting error here. A local variable with similar name exists. Okay. N. So don't worry about this. What is happening here? Okay. Cannot find value x in this scope. Why? Because we created x inside of a set of curly braces. Anywhere you see a set of curly braces, it's a new scope. So when you create a variable inside this scope, as soon as the scope ends, the variable is destroyed. So it is no longer available. So outside this block, okay, curly braces, you will not see the variable x at all. However, if I put this print line, if I have this print line in here, okay, there is no error here because x is actually visible here. Okay, x is there inside the scope. So therefore, you can see this value. However, here you cannot because the variable has got destroyed by the time, okay, the compiler reached this point during execution, where the scope ended and the variable is destroyed. Okay. Now this behavior is similar to C, C++. So I can now just comment this line and I can just run this. So the value is x is 99 and n is 10, that is coming up, right? So this tells you that when a scope ends, the variable is destroyed and so is the value. Okay, the value will also get destroyed, right? Okay. Now, so again, these are the three important rules you should always keep in mind. Okay. A value can have only one owner at a time. Any value for that matter. Okay. You can only have one owner. Right. And every value has to have an owner. You cannot create values without having an owner. And at any point in time, there will be one owner. Okay. And when the owner goes out of scope, the value will be dropped. So just like you have this delete function in C++ or the free function in C, you have a drop function which is used by the compiler to drop the values. Okay. Now, here is the string type. Okay. So to actually illustrate ownership, we need a data type that is more complex than those we covered in data type section. So that's the reason why we are actually using string as an example. Okay. Right. So what goes on in here? So if you want to create a string, okay. If you want to create a string, then you'll have to create a string like this using the string from function. Okay. Right. So you can create a string from a string literal using the from function. like this. Okay, so for instance, let me just show you. So this- okay, to create a string. Creating strings. So if I did something like this, let S1 is assigned, let's say as A, B, C. Okay. And let S2 is assigned from. Okay. Now, if you see here, the data types of both these are different. Okay. Data, both these are different. One is ampersand stir. So this is called as a string. So this is actually, when it comes to strings, you have, it's called as string slice. We'll be talking about this in detail later on. But for now, okay, it's a string type, whereas it's a string slice. So whenever you want to create actually string type variables, you have to use string from. Okay. Now, there's a reason I will discuss this at length in the next session, wherein you will be able to understand how strings are handled in Rust. Okay, so that is something that can get tricky because this being a low-level language, okay, strings are kind of a little different from how other languages use, because other languages use higher-level abstractions, which make usage of the string much simpler. But Rust being low level, so it has low level details which you will need to understand in order to be able to use them, okay, effectively. But again, remember, it is not that difficult. Once you understand the whole concept, it's actually quite simple. Okay, so there are two ways. One is you can create strings using string slice. Okay, the other is using the string type. Okay, right. So when you create these strings, actually this string that you see here, it's actually a UTF-8 encoded growable string. You see there? That's the definition. Okay. And you can look into this, so many, what to say, and these are all Unicode strings. Okay. So you can have, you can actually put like, as they have shown here, you can put, international characters, okay, whatever that you want, right? But if you see here, ampersand str, okay, it's actually string slice type. Okay, and we'll be talking about that a little later. Okay, right. So let's talk about ownership. Okay, so I'm going to comment these two lines, and I will start off with the string. Okay. So let's say let S1 is assigned string from ABC. Okay. And I define line S1 is S1. And again, 2 is assigned S1 and okay, and I display S2, and you can see here there is no error, and I can actually run this. So I'm getting ABCD. Sorry, not S1. Here I need to make it as S2. My bad. Okay. So we see that S2 is coming out as ABCD. Everything is fine. Now, if I try to display S1 all over again, okay, I'm going to get an error. This is actually an error. Borrow of moved value. Okay. Borrow of moved value. So if I save this and try to run this, in fact, and you see here, so move occurs because S1 has type string, which does not implement copy trade. Don't worry about this copy trade now. We'll talk about that later. Okay, so it has created the string. Okay, and now the value is moved here. Okay, so what does it mean when you say a value is moved here? Okay, so that's what I want to show you here. So I'm going to remove all this stuff. Okay. Right. So let's say when I define a variable, let S1 is assigned string from okay, ABCD like this. So what happens is that, again, remember, it has nothing to do with stack. This is actually the code. Okay. And in the memory layout, what will happen is that you will end up creating an S. Okay. So your ABCD is here. Okay. And let's say the ABCD we have it at some address, let's say 1122, something like this. So your S1 is here, and it has got the address 112. And so basically this is pointing to, okay. Now, when you say after this, say let S2 is assigned S1. Okay. See what goes on in here. So basically what will happen is that it will actually create a new variable called S2. Okay. So one of the things, okay, what exactly goes? So what is the value in S1? The value is not ABCD. The S1's value is the point, the address that it is containing. So basically what is happening is that you are copying this address. That's what is actually happening. So 1122 gets copied into S2. Okay. But then what actually goes on in here is that when you do it like this, okay. So essentially what you're doing is you're changing the hands of ownership. So basically what happens now, this pointer, now S2 is pointing to this ABCD and S1 is basically invalidated. Okay. Okay. This whole thing is actually invalidated. Okay. Okay. And this has got no. Oh, I'm sorry. I have to put a rectangle over there. Okay. So this has become invalid. Therefore, S1 is not a valid pointer anymore or valid reference anymore. That is the reason why once, so basically what you're doing, the value is getting moved. Okay, it's not getting copied. In other languages, the value will get copied. Okay, or okay, what happens is that basically if it's other languages, okay, so this is in Rust, this is what will happen. Okay, so we can say that I can just put it over here and I say this is okay. So in Rust, this is what will happen. But if it is other language, let's say let's take this further. Okay. Let's say if this is say C++, okay, and I create string S1 is signed ABCD. String is actually allocated in the heap memory. Okay, so right. So it will also have 1, 1, 2, 2. Okay. So what is happening? In Rust, we use the move. Okay, it uses what is called as move. Sometimes it's also referred to as move semantics. Okay, let's keep it simple. Okay. This is move. And in C++, it's copy. Now, in order to save memory, what it does, what C++ does, it does not copy the content. It only copies the, it doesn't copy the ABCD as such. Okay, it does, it keeps the same string. However, it uses 2 pointers or 2 references. Okay. Now, there is a problem with this sort of feature, which is where, memory management comes into play. Now, let's suppose somebody at some point in time, okay. Of course, here also I need to make string S2 is assigned S1. This is C++ code. Okay. So in this case, what will happen is, so basically the pointer is copied. Now this, once a pointer is copied, at some point in time, if somebody deallocates memory through S2, then what will happen? This memory is deallocated. And so now S1 is pointing to an area of memory which does not belong to anybody. And so when S1 is going out of scope, it will also try to deallocate. And that leads to memory corruption, which is also called as the double deallocation problem. Okay. That's called as the double deallocation problem. So this can lead to double deallocation problem. But look at the Rust part. Because it is using a move, okay, the ownership has changed hand from S1 to S2. So if S2 goes out of scope, this area of memory is freed up. Or when the S1 is going out of scope, S1 is destroyed. But since it is an invalidated pointer, there is no deallocation taking place. Only S1 is destroyed. That's it. Okay. This is the mechanism which it is using. So Rust uses the move. So basically what happens when you take a complex type and then assign it to another variable, okay, then the ownership changes hand. The ownership is transferred from the source variable to the destination variable. Okay. Any questions here? I don't see any questions there. Any questions, please? Yeah. If S2 is deallocated, then will it be accessed by S1? Are you talking about C++ or Rust? So in Rust, okay, if S2 is deallocated, right? Call by reference, call by value, one side, it's a bit different from that, okay? It's a bit different from that. It isn't really call by value or reference, okay? Because I have not used any functions. So Rust now we cannot use S1 anymore, right? Yeah, that's true. So basically, again, remember, Abdul, what you're saying is if S2 is deallocated. See, in Rust, what happens is that when you take the value of S1 and assign it to S2, what happens? The ownership changes. So S1 is no longer the owner of this ABCD. Okay. So this pointer is actually invalidated. Therefore, even if S2 is destroyed, or even if it is available, S1 cannot be used anymore. because now S1 is invalidated, therefore it does not have access to anything. It's an invalid pointer, invalid reference. Okay. It's an invalid reference. In C++, if one deallocate, we cannot access both. That is true. That actually leads to memory leak problems, memory issues. Okay. So, Shiv Kumar. So basically, what is happening? How can I access them? First two sessions. Indupriya, I didn't get your question. Okay, so let me answer this. In C++, if one deallocates, we cannot access both. Yeah, that's true. If you, let's say you deallocate the memory through S1 or through S2. Okay. If I deallocate it through S2, I cannot use it with S2 or S1, both. Because once it is deallocated, the pointer is no longer pointing to a valid memory address. Okay. S1 will get destroyed or not? Oh, Sudarshan, this is the question I was actually waiting for. You need to ask question like this. See, S1 will only get destroyed when it goes out of scope. Just changing of the ownership doesn't make it go out of scope. So see, let's see here in the code. So S1 is still in scope. See, the S1 is still in scope. This variable is there, but this is an invalid reference after this statement. After this statement. Okay, S1 is still there, but you cannot use it. You cannot use it, but it is still there. Why? Because it was, where was it created? Inside the main function, right? Only when the main function ends that S1 will get destroyed. And of course, S2 also, because S1 and S2 both are created inside the main function. Fantastic. That's the question you should be asking. So Sudarshan, is it clear? Okay. Indupriya, I think you're talking about the first two sessions. Please, I told you not to use the Q&A for anything other than the topic that we're talking about. Okay. If you want to talk about that, please use the Discord. Okay. So even though the variable or the reference is still there, it's an invalid reference. That's the reason. The compiler actually knows, because once it sees this assignment, the compiler knows, hey, the ownership has changed hand. S1 has become invalid. So anywhere you try to use S1, it is going to give you this error that, hey, you are trying to borrow off moved value. You are trying this borrow off moved value. Okay. So compiler is pretty, what to say, smart in knowing what is going on in here. And this is happening because of the move semantics that we are actually using. If it is copy, there is no way the compiler knows about these. Okay. And in fact, it doesn't need to, because these are two different copies. Okay. Okay. Now, when you talk of ownership, okay, now see what happens. Even if I create this inside of a block of code like this. Okay. Now what has happened? I have created a new scope, right? But then again, this assignment will change the ownership. So S1 again becomes invalid. Therefore, after this block of code also, you cannot access it. Okay. The value has already moved. Therefore, it's not possible to access it. Okay. So now what I'm going to do is insert. Okay. Let's define another function. Okay. Hmm. String length. And what it does, it takes in a string. Okay. So I have say, X is of type string. Okay. And let's say maybe I do this. Show uppercase. Okay. And what it does, it takes in a string. X is of type string. So this is a procedure, okay, because it is not returning anything. And what it does, it uses print line, okay, and original string and the uppercase string. It just displays, okay, it doesn't do anything else. So I have X, okay, X dot to uppercase. And then say, okay, I call this function show uppercase and pass in the string S1. Okay. So now see what happens when I run this code. It is running. Original is ABCD, uppercase is capital ABCD. So far, so good. But see what happens if I try to access S1 again after the function call. Okay. After the function call, if I try to display S1, see again, the value moved here. Now, this is a typical situation you will actually run into. Okay. You will actually run into. So basically what is happening? So even if you pass this string, okay, into a function, then also what is happening? So basically this is equivalent to as if you are taking S1 and assigning it to X. So what does that assign do? It basically, okay. What does the assign do? It simply changes your ownership. Okay, so the ownership has changed hands. So displaying S1 before the function call works fine. But after the function call, the ownership has already been moved to X. And therefore, S is again invalid. So at this stage, you cannot do it. Okay. Right. So this is what actually the whole point behind moving of the references from one variable to another variable. Okay. So the question is, how to avoid this? Can we avoid it? So let's see. Okay. So let's call this as show uppercase V1 for version 1. Okay. So let's and I'll take this function. And this is my V2. Okay. And what I do is I take, instead of string, I take a string reference. Okay. I take a string reference. So I just comment this out. Okay. And sorry. And this time around, I use. Okay. But because this is a reference, okay, you cannot pass the string as such. You have to pass a reference to the string. How do you do that? You put an ampersand. It's just like passing an address. Okay. V1 is never used. Show uppercase. Should I make this? Oh, sorry. This. Yeah. Okay. Yeah. Okay. And I'll also put this annotation here for the unused verbs. I think I already put it up elsewhere. It's already there. Unused variables. Of course, I'll have to use. Right. So that unused functions, okay, will not throw up warnings. Okay. And after the function call also, this is working. Now, let me just run this and show you. See? S1 is ABCD, original ABCD, uppercase ABCD, and then after the function call, S1 is ABCD. So S1 is still accessible. Okay. S1 is still accessible. So what is happening? So this time around, what we have done is we have actually passed a reference. We have not passed the actual owner. We have passed a reference. So that reference gets stored in here. Okay. So basically X takes a temporary ownership, uses it and relinquishes it. So it does not affect S1 original at all. Okay. It does not affect the original. Now let's see questions. So I didn't get any emails. Deepak Chaudhary, I would recommend that if there are any Q&As, anything other than the subject matter, okay, you just discard these, just dismiss them. Okay.
Sure.
Yeah. And mark them as so all the other things, just mark them as answered. Okay.
Yeah.
Okay. Right. So now let's look at this. Okay. Now, so for simple types and all, okay. Simple types, if it is say just integers, then you don't have an issue. But the moment you use a string, okay, it's a complex type, and then you will have an issue of the ownership and this coming up. Now, important thing for you to remember, okay, right, is how the strings are actually represented. So internally, string is a specialized structure type which has got the pointer and the length and capacity. This is how essentially the strings are represented. Okay, inside of the memory. So if you create a string, when I say string, remember I'm not saying string slice. Okay, I'm talking about string with a capital S. Okay. Deepak, just Devisri's Prem Kumar this Q&A, so just discard this.
Yes, sir.
Yeah.
We'll sort it. Yeah.
Okay, so now remember one thing. So what it does is that it actually holds three pieces of information. One is the pointer, which contains the address, and this part that you see here, okay, this whole thing is actually inside the heap memory. This may be in stack. Okay, this is in stack, but this part, the dynamically allocated thing, is inside of the heap memory. Now, what it maintains is the pointer to the starting of the string, okay, which is basically an address, nothing beyond that. It also holds the length of the string. So it knows, so basically it already knows the length of the string. So it actually stores it here itself. Okay. And also there is a capacity. So right now length and capacity are 5 and 5 each. So which looks actually similar or rather same. But to tell you the truth, the capacity can be 10 or 20 or even 30 or something like that. Okay. So what capacity indicates is the actual memory, amount of memory that has been allocated. It would be minimum the length of the array, length of the string, or more than that. So the allocator which is allocating memory. So when you ask it to basically create a string with this hello, it will obviously create a string in the heap, put hello in here, take the starting address, put it in the pointer, set the length as 5 because 5 characters, 1, 2, 3, 4, 5. This is the length of the string. But it may allocate a block of memory, which may be maybe 10 or even 15 characters. So the capacity will become 10 or 15. Or any value as per the allocator's actual allocation. Now, why this is so? This is so because for purpose of efficiency, because what happens is this string that you see here is actually a growable string. Okay. Which means that you can actually, the string can actually grow and shrink. So if you allocate a little bit of more memory for allowing it to grow, then you don't have to reallocate all this space. You can just add in additional characters at the end without having to copy this entire block. So this is basically a kind of optimization that that Rust actually internally uses. Okay, right? So when you assign S1 to S2, the string data is copied, meaning a copy. So basically this whole thing is copied, right? Okay, pointer, length and capacity. So basically the pointer is getting copied. So it has a copy of the pointer, length and the capacity. Okay, now the representation does not look like this. So when you say S2 is assigned S1, okay, it's not like it is going to create a new copy of the entire data. So basically it is going to copy this pointer. So therefore both these pointers are going to point to the same area of memory. Okay. Right. Now, see here. So we said that variable, when a variable goes out of scope, Rust automatically calls the drop function and cleans up the heap memory. So if you try to do it like this, then what happens is that suppose because you created S2 later, so this is going to go out of scope before, right? Because usually always the variables which are created later are the ones which will actually get destroyed first, right? So once S2 is getting destroyed, it is going to destroy this value. Once this value is destroyed, S1 will point to an area of memory which is basically invalid. Okay, so this kind of problem will come. Okay, so therefore, when you do it like this, okay, it does not use whenever you do this assignment, okay, it doesn't do this one. Instead, what it does is that basically S1 will be invalidated and then the ownership will be transferred to S2. Okay. Right. So this is known as move. Okay, this is known as move. Right. So basically the ownership has changed hands. So what actually happens is this. So in Rust, when you take S1 and assign it to S2 like this, the value will get moved. So basically the ownership has moved from S1 to S2. Therefore, when S2 goes out of scope, this value will get destroyed. Okay. And when S1 goes out of scope, there is no value it is pointing to. It is already invalidated. So therefore, nothing happens. Okay. So because Rust also invalidates the first variable, instead of being called a shallow copy, it's known as move. So in this example, we would say that S1 was moved into S2. So what actually happens is shown here. So this is exactly the mechanism that is being used, which is what I've shown here. Okay, it has moved. So basically that pointer, I just removed the pointer for clarity's sake. Okay, right. Okay. So another thing that you have to understand is what is called as a shallow copy or a deep copy. Okay. There's a concept of shallow copy and deep copy as well. When you say shallow copy, okay, so this is basically this is a shallow copy. Okay. Right. If it's deep copy, so let me just. Which is also used by many languages. Okay. So if it is a deep copy, you know what will happen? So basically, there's deep copy, which means, okay, C++ usually uses shallow copy, okay, and say if you are using, let's say, other languages, so it can be a deep copy, in which case what will happen is the memory is still allocated on the heap. However, when you are assigning it, so what the compiler does is that basically runtime environment does is that it actually takes in the data that is being pointed to, and it creates a copy of the data in memory, and then it assigns it. that address is stored in here. This is called as deep copy. So in shallow copy, you're only copying the pointer or reference. Whereas in deep copy, what you're doing is you're copying it, the entire data itself. So these two strings, S1 and S2, are completely two different strings. Any change to S1 will not get reflected in S2 and vice versa. In shallow copy, what happens is any changes to one of the variables will be reflected as a change in the other variable. In move, the ownership itself moves, therefore the older reference becomes invalid. Is Rust deep copy? No, it is not. It is shallow copy with move. Okay, so we call this as move. It is a shallow copy because it is copying the pointer, that is address, not what it is pointing to. Okay, but it uses shallow copy with move, so the ownership changes hand. Whereas in C++, it is a shallow copy without move. If you want to do a deep copy, so the result of deep copy will look like this. Okay. Now in C++, you can do both shallow copy as well as deep copy. Okay, but the thing is, when you do a deep copy, you use other functions to create a new copy of the entire, block of memory. Okay. But then what happens is when you do deep copy, you are essentially wasting a lot of memory because it's the same content. So shallow copy is actually efficient in terms of usage of memory. Whereas deep copy, because it creates a complete copy of this memory block, therefore it's actually not that efficient. It uses more memory. Also, the whole process of creating a block of memory, allocating a block of memory in heap, and then taking the address of that block and then putting it in the variable is very expensive computationally. Also, it actually uses more CPU cycles, not to mention more memory as well. Okay, so therefore this is very inefficient. So shallow copy is actually efficient, but it has got its own problem. If it's a pure shallow copy, then double deallocation problems will come up. Okay. Now, see why deep copy is inefficient. You might say, hey, it is just 4 characters, right? That's true. But imagine you're writing a mathematical software where you have 100 by 100 matrix. Which has got 10,000 values, 10,000 multiplied by 32 bits. Okay, so imagine you are using 320,000 bytes, and so that whole memory has to be copied all over again if you are going for deep copy, which is not efficient. And not to mention, if you want to make changes in place, then in that case, that whole mechanism is actually will not work. Okay. So therefore, deep copies generally are avoided until and unless you need to do that explicitly. So now the question is, can we do deep copy in Rust? Yes, we can do a deep copy. Okay, you can do that. If you want to do a deep copy, okay, then there is this clone method on string which can be used. So when you say s1.clone, okay, so what you're doing, you're creating a clone. That means you're creating a new copy altogether and then assigning it to S2. So S1 and S2 are 2 different strings altogether. Okay. So okay. So I can actually show you in code as well. So suppose, for instance, if I did something like this, S2 is assigned S1.clone. Okay. New copy of string. Yeah, it's a completely different object. Okay, so anything you do with S1 will not get reflected in S2 and vice versa. Okay. Sorry. Okay, so again, this is also type of string. Right, any questions? I see. At the end of the session, could you please show how to set up Rust in VS Code? Dot clone is used for deep copy. Yes, Abdul, it is used for deep copy. Okay. Okay, any other questions, please? Okay. So this is a complete copy. Okay. Now, suppose I want the function to modify the value. Okay. What I want to do is I'll call this as make uppercase. And what it does is that it takes in a string okay, and then what it does is that it let's see, say or let me just let's look at this. Uppercase, and it returns the uppercase equivalent of the string as a new string, but we want it as a string itself. Okay, so let's do one thing. Say let's call this as and and let's say what I want to do is something like this. Okay, I have this welcome. Okay, and then I wish to add the username to this. Okay, so add username, and I want to do is I want to pass in the string X and also a username. Let's say okay, and then don't worry about this error. I'll okay. So here when I display this S1, I should get welcome, and here when I display this, I should get welcome Ram. Okay. So I need to have the original string, and also I need to have say another thing, say user. Okay. So again string, and how you do that is you just say start push string, and then you can pass in a string, say user. Okay, appends a given string slice onto the end of the string. So I'll just say that. Okay. Now, instead of borrowing here, okay, pushes str. Okay. So first off, cannot find value of x. So sorry, this should be S1. So enter S1. Okay. So I'm passing the S1, and then I'm using this one. Okay, expected string but found. That's just a minute. Okay, don't worry about that. So here, what I do is say, okay, if I put it as string slice. Now, again, the problem is I'm actually trying to modify the value of x. Am I right? Okay. So what happens is, because x is being used or S1 is being passed in, okay, into the string. So what will happen? The borrow will have, sorry, the ownership will change hand. Okay, so therefore S1 will become invalid again. So how to avoid that? We saw that previously. We can do that by passing in the reference. Okay, so what we do is we pass in the reference. Okay, so I'll pass in the reference. So instead of S1, I'll pass a string reference in here. Okay, and I'll say that this is a reference to the string. And I say this. Okay, but I still get this error. And what it says is that okay, cannot borrow star x as mutable as it is behind a reference. X is a reference, so the data it refers to cannot be borrowed as mutable. So now I see the whole point here is that the situation I'm into is that I want, when I pass in this string with a username, that username should get appended into the string itself, which means I'm trying to modify the string. But can I cannot, because even though I'm taking a reference, okay, this string is immutable. S1 is immutable. So the reference I have created is actually an immutable reference, which means that this reference cannot be used to modify the data. Right? So what I need to do is I need to say that S1 is mutable. Now that I have made this mutable, okay, variable does not need to be mutable. So what happens is, again, I'm still having this problem. Okay, cannot borrow this x as mutable as it is behind a reference. So what we need to do is that you have to say, hey, this is, it's a mutable reference to a string. I always have this one. Okay. Now it works. I'm saying, hey, it is a reference to a mutable string. Okay. And here also, when I pass this, okay, I have to be explicit. I have to say, hey, you know what? This is a reference to a mutable. So, now you might be wondering, why do I need such complexity? You see, you have to be extremely verbose so that you are actually expressing your intent, exactly what you want to do. Therefore, the compiler will not have to make any guesses. Okay. It does not have to make any guesses. That is where the whole thing actually works. Okay, so I can take a mutable reference. Mutable reference means a reference which can be used to mutate. Mutate means to change the value. That's what I want. Okay, without changing the ownership. So what happens is it's a temporary ownership. So borrowed has happened. So borrowing is the mechanism of creating temporary owners, which will work and then relinquish control. Okay, so now if I try to run this code, see, initially S1 was welcome, now it has become welcome Ram. Okay. Right? Okay, so I see one question in here. So what push str will do? It will push a string to the end of the existing string. See, this is what it does. Appends a given string slice onto the end of this string. Okay. Any other question? See, this whole mechanism is extremely important for you to understand. Okay. And also one final thing that I want to discuss is this. I'm going to remove this function. I'll create a string. Now you might be wondering, why is it that I'm using string so much? That's because the string is the easiest data type to actually understand, borrowing and ownership. Okay. So let S1 is assign string from ABCD. Okay. So let's create a reference. Okay, so I'll say let say reference to S1 RS1 is assigned. I'm creating a reference now. Okay. So it's a reference to S1. So as you can see here, there is no error. Okay. Right? Okay. Now, if I create another reference, let RS2 is assigned reference to S1. No errors. Okay. Right. Creating to, now these references are immutable references. Okay, immutable references. Okay, so this is fine. Okay. Now I create let's create a mutable reference. So I say let mute say M or S1, mutable reference to S1. Say, okay. Reference to S1. Okay. Now you see there, variable does not need to be mutable. Okay, remove this mute. Right? Or if I say okay, so this is a reference to string S1, you'll start getting errors. Okay, it's a mutable variable or reference. Mute can be used anywhere. So suppose if I okay. So it's a reference to a mutable string, but the string is not mutable, it is immutable, right? Therefore, this mute keyword has no role to play. You cannot have a mutable reference to an immutable string. Okay, so that's an error. Mutable reference to immutable string. Okay, right. Now what I'm going to do is we'll create two mutable references. Okay, so let's call this as mutable reference. And here, okay. Oh, I'm sorry. Okay. So I'll create this string as mutable string. Okay, so you see, no issues in here. A mutable reference or a pointer. Okay. And what I do is I also create another mutable reference to S1. Okay. Right. So up till here, everything is fine. So this is where actually the confusion really starts. Okay. So for instance, now if you happen to call some functions, okay, if you happen to call some functions, then you start running into problems. Okay, like for instance, if you say print line mutable reference to mutable reference this one. Okay, you'll start getting these. Okay. This may seem a little daunting, but remember, before this print line, it was all fine. Okay. But the moment you start doing it like this, you start getting errors. Okay. Why? That's because it's actually print line macro will expand to a function. And then what happens is basically the ownership has changed. So this no longer is valid, right? This is no longer valid. This is the, so because of the ownership change, okay, this statement doesn't compile. Okay. What if you add ampersand and just write mute string? Will that work? Immutable reference for mutable string. Yeah, you can have a mutable string and you can have a immutable reference. Okay, that's allowed. That's perfectly fine. So like this. So again, this is giving error because it has already been borrowed. So S1 has become invalid. So suppose if I remove this, it will work just fine. See, you can have a mutable string and create immutable references. Okay. That's because immutable references are read only. Whereas mutable reference means read write. They have read and write access. So immutable references can only read. So any changes to the string must be carried out only through S1 only. And these references will see the changes. Okay. But you don't want to run into a situation where you have a read-only reference and there's a write reference also, which can actually change the data. That can lead to all kinds of memory corruption related issues. And that's why a combination of mutable and immutable references is not allowed. Okay. Okay. So if you see here, the rules are very clear. Okay. So I'll just show you here. So what I want you to do is I want you to read through this page. Okay. Right. So there are a couple of rules. So basically, when you use references, so read through this. Okay. Okay. Two or more pointers access the same data at the same time. This is a data race condition. At least one of the pointers is being used to write the data. There's no mechanism being used to synchronize access to data. So rules for references. At any given time, you can have either one mutable reference or you can have any number of mutable references. Okay. And the references must always be valid. References must always be valid. So these are the two rules you have to keep in mind. Okay. That's what this whole thing about references and borrowing. So basically what is happening. So let me explain here. Okay. So if you create this S1, okay, from hello. Now you see I've created a reference. So when I pass a reference, what actually happens? So you see, the issue is we can provide a reference to a string. So what is a reference? A reference is like a pointer in that it's an address we can follow to access the data stored at that address. That data is owned by some other variable. So when I'm passing in this address of S1, it gets stored in S here, but this S is only accessing the value. The ownership has not changed hand. If I'm passing in S1 itself, not ampersand S1, then only the ownership changes. So a reference is like a pointer that's in that it's an address we can follow to access the data. That data is owned by some other variable. So unlike a pointer, a reference is guaranteed to point to a valid value of a particular type for the life of that reference. That's where things actually change. So when you pass in a reference, okay, you are not handing over the ownership. You are just giving a copy of the pointer. Hey, you know what? Use this pointer, access the data. But again, remember, accessing means only read the data. You can't make changes to it. Okay. You cannot make changes to it. So basically what happens? See, S1 contains the entire string here, but S only contains the pointer. It uses this pointer to access the data. It can only read. Okay. So these ampersands represent references. They allow you to refer to some value without taking ownership of it. So the ownership has not changed. So even after this function called calculate length, our print line will still work with S1 because it is still the owner. Okay. Right. Okay, guys. So that's it from my side. So for today,
All right, sir. Have we discussed about the assignment?
yeah, assignment. So Deepak Chaudhary, you can just show them the assignment.
Yeah.
So guys, I'm just giving you okay. References and borrowing page link. Okay, you can directly go there and read through it. Deepak, I'll stop the share and then you can start the share. Okay.
Yeah. My screen visible?
Yeah, but this is session 2, module 2.
Yeah.
We want today's assignment.
Yeah, so just for everyone's information, guys, we will be sharing this form link for the assignment that we had for session 2 as well. So session 2 and session 3, both the assignment forms will be shared with you here. So if you have completed the assignment, just update it in the update the forms here.
Also, you will get the question here, and you need to upload the code in the long answer text here. And if you face any problem, you can copy it and paste it here. Also, if you successfully do it, you need to paste the output also.
Yeah,
And
if you guys
just
need
let me, Chaudhary, just go up a little bit. No, I just want to explain the assignment. Can you come down? Yeah, so you have to generate first n Fibonacci numbers, okay, such that the output looks like this. So for n equal to 10, so either you can hard code the value of n or you can take it as an input. I would recommend that you use it as an input so that you get some amount of practice using the standard libraries IO as well. So you start with two values, 1 and 1, and the output should be 1 unique, 1 unique. After that, rest of the 8 values, okay, 2, 3, 5, 8, 13, 24, 21, 34, 55. Every number needs to be tested. So 2 is even and it is prime. 3 is odd and it is prime. 5 is odd and prime. 8 is even and so it is not prime. 13 is odd, so it is prime. 21 is odd, but it is not prime. 34 even, not prime. Okay. 55 odd, not prime. And then finally, the sum of these numbers. So all the way, all these 10 values. So this is what you have to do. You have to use proper loops and functions to do that. Okay. Right. So we can start the quiz now. Someone is asking, how can I access the Rust language theory displayed on screen? I showed you the Rust book. Okay, go to Rust book. And go. Okay, guys. So your Deepak, this is the quiz, right?
Yeah.
Okay.
Yeah, guys, so the quiz time has begun, and we'll take 15-20 minutes for the quiz. And once you complete the quiz, feel free to log out. All the best. And we'll be sharing the quiz links, sorry, the assignment links here as well. Deepak, if you can share both the links of the assignment for today and the earlier session with the dates so that people can just go and put it there.
Yeah.
Yeah, so we have shared the quiz link again, and also the assignment link for 6th Feb, which is today's session, and also for the 3rd Feb session. So you guys who might have missed it earlier can access it now.